Hello guys, welcome back to our YouTube channel. Today we are discussing some important questions of applied physics for computer science stream. The subject code is BPHYS101 and 202. 102 and 202. Module 1. The first question is define laser and discuss the interaction of radiation with matter. The second question is obtain the expression for energy density using Einstein's A and B coefficient and thus consider on B12 is equal to B21. The third question is describe the attention and explain the various fiber losses. The fourth question is discuss the types of optical fibers based on the modes of propagation and RI profile. The fifth is numericals. The first question is a laser source has a power output of 10 to 3 watt. Calculate the number of photon emitted per second given the wavelength of laser 692.8 nanometer. And the second question is obtain the attention coefficients of the given fiber of length 1500 meter given the input and output power 100 meter watt and 70 meter watt. Third problem is calculate the ratio of population for a given pair of energy level corresponding to emission of radiation 694.3 nanometer at the temperature of 300 K. And the sixth question is discuss point to point communication using optical fiber. Module 2. First question is derive an expression for de Broglie wavelength by analog and hence discuss the significance of de Broglie waves. And the second question is step Schrodinger time independent wave equation in one dimension. And the third question is state and explain Heisenberg eternity principle and principle of complementary. The fourth question is explain the physical significance of the wave function. And the fifth question numericals. The first numerical is calculate the energy of the first three states for an electron in one dimensional optical well of width 0.1 nanometer. Second question is an electron is associated with a de Broglie wavelength of 1 nm. Calculate the energy and the corresponding moment of the electron. The third question is an electron is a kinetic energy 500 keV is an vacuum. Calculate the group velocity and de Broglie wavelength. Assume the mass of the moving electron is equal to the rest mass of the electron. The next module first question is define a bit and qubit and explain the properties of qubit. Second question discuss the C0 gate and its properties for the different input state. And the third question is a linear operation x operates such that x of 0 is equal to 1 and the x of 1 is equal to 0. Find the matrix representation of x. And the fourth question state the Pauli matrix and apply Pauli matrix on the state of 0 and 1. Fifth question is evaluate the difference between the classic and quantum computing. The sixth question is explain orthogonality and orthonormality with an example for each. And the seventh question is explain the representation of qubit using block sphere. The next module, fourth module, the first question is define Fermi factor and discuss the variation of Fermi factor with temperature and energy. And the second question is describe Misner's effect and hence classify superconductor into soft and hard superconductor using MF graph. And the third question is enumerate the assumption of quantum free electron theory of metals. And the fourth question is explain the phenomenon of superconductivity and discuss the quality qualitatively the BCS theory of superconductivity for negligible tens of metal at temperature close to absolute zero. And the fifth question is numericals. The first numerical is calculate the probability of occupation of an energy level 0.2 electric EV above Fermi level at temperature 27 degrees Celsius. The second numerical is lead as a superconducting transition temperature of 7.26 Kelvin if the initial field of at 0 Kelvin is 50 into 103 am power 1. Calculate the critical field at 6 Kelvin. Third numerical is find the temperature at which there is a 1% probability that a state with an energy 0.5 electric watt above the Fermi energy is occupied. The last question is give the qualitative explanation of RF speed with the help of neat sketch. The last module, first question is discuss the timing in linear motion, uniform motion, slow in and slow out. And the second question is distinguish between descriptive and descriptive statistics. The third question is illustrate the odd rule and odd rule multipliers with a suitable example. And the fourth question is describe the jumping and parts of jump. And the fifth question is discuss modifying the probability for proton decay. The sixth question is sketch the explain the motion graph for linear easy in and easy out case of animation. And the seventh question is numerical. The first numerical is slowing in object in a animation has a first frame distance 0.5 meter and the first blow in frame 0.35 meter. Calculate the base distance and number of frames in a sequence. And the second numerical is the number of particles emitted per second by a random radioactive source has a Poisson's distribution with lambda is equal to 4. Calculate the probability of p of x is equal to 0 and p of x is equal to 1. And the last question is describe the calculation of push time and stop time with example. Thank you for watching our video. Please do like, share and subscribe.